Hey, how's it going? Whew. All right, I just want to check in and show you guys what is going on. I've been doing a lot of work on the ship's movement. So when I'm talking about the ship's movement, I'm really talking about um, like a multifunctional movement component that could be given to AIs and it could be given to the player. It's going to be used to snap the ship to the hand or to ease the ship to the hand, and it's also going to be used to interpolate through static points for the AI or possibly moving points for the AI. So it's kind of like a fly-by-wire system, and sometimes it can be used from a couple of different systems. So it's kind of taking on a lot of functionality, and it's becoming very useful. And I've kind of reimagined this system a couple of times, and I'm probably going to do it one more time. So I'm actually not going to get too far into the math of what's going on, because I think it's going to change anyway. But basically, what I've got going on, or what I need to do, is I've needed to set up a physically based movement system. Right here, I have the old movement system, and he's going to snap to the hand. He's actually not got forces associated with him. He's actually just setting X and Y and Z positions, and his rotation, his orientation is set to look at the direction of velocity. So things are just being set, and the disadvantage there is I can't have things really interacting with it, except for just being maybe blocking or maybe interpolating velocity, and have it be like, oh, well, imagine this particle got hit by a imagined velocity of this much, and there's just no concept of mass in that. So I'm having a need for a physically based system. I want it to react to getting hit by lasers, hit by explosions, hit when it scrapes the surface of something. I want it to react, and I may even introduce turbulence, turbulence forces for like simulating wind. Excuse me, I just got back from a run, got the coughs, and yeah. Anyway, so I have a need for the physical system, and I need it to be open for the AI as well as the player, and I need it to ease to moving points, and I need it to move to stationary points, and I need it to fly through points. I need it to do a lot of stuff. So in this video, I'm gonna pack a lot in. I want to show you, basically how I set it up. Wow, it flew me anyway, wherever. Okay, basically how I set it up was, let's get back over to wherever the heck I was. Here it was. I basically put it back to back with the system that I had before and made sure the results were about the same. This system I don't really have that much control over, the far one, and the close one, I have all the control I want. Here's how it works. I drop in a spring flight movement component. It's got some default properties. You can put it on any component that is physically based, meaning it simulates physics, has mass, has collision. Collision is necessary because that's how the inertia tensors are calculated. So without collision, you would not have an inertia tensor. And in other words, you wouldn't really know how much torque to apply in order to rotate it a certain amount, which is necessary for, a physically based torque system. So anyway, you have these inputs. You have linear stiffness, which is the stiffness of the spring that is imagined between here and, let's say, the target point. You have the linear critical damping, which is derived from the mass and the linear stiffness of the spring, and it is damping in the direction opposite of velocity to slow you down a bit. That's the thing that will slow you down when you're close, or when you're fast, rather. Yeah, it's a pretty simple topic. I don't really want to go into much of it, but basically, it's derived from mass and linear stiffness, and that's all we really need to talk about. Linear max speed is basically, when I set this on, does it have debugging on? Yeah, it has debugging on. So right now, let's say linear max speed is like 50 centimeters per second. Can't even see it actually. 50, let's make it more like 100. So the green is representing how much. You could kind of imagine like this. It's not really a force between the point and the target. It's actually, when you limit the maximum speed, you're essentially, what I've done is essentially limited the extension of the spring. And I did that by saying, well, I know I'm going to make an equilibrium statement that the damping force should be equal to the spring force in order to achieve a constant velocity. So when I set the maximum speed, I'm internally setting the maximum displacement of the spring system, as we can imagine. It's really cool. The way that this is set up, it's incredibly useful because I've set it so that it can target a moving point. So in this case, this point has velocity. This is like the point might be the hand of the player, and you can see the spring uses right into it. That's because I'm actually computing in the damping force. I'm computing it as if it's in the same inertial frame as the moving target. So, excuse me. So it's really useful because now I can say that the max speed is actually more like the convergence speed on that point, or I could not do that. I have the control. I've also got a couple more settings for AI so that it maintains maximum speed, meaning it's always going the maximum speed. It's always treated as if it has the maximum extension. Really useful for AI, which is what I'm going to show you. So it doesn't ease into the points because maybe the points aren't moving in this case. The points are picked throughout the world and they're stationary, and I want my AI to fly through the maximum speed and find the next point. Because that's kind of how the AI works. It's not really moving around a point continuously. It's picking points discretely about where it wants to be and moving them around quickly so that it repositions. That's kind of how I've built it. Over here, you have the same sort of test, this time with a static mesh. It's much heavier, and I've adjusted the coefficients and just wanted to make sure everything was looking right. In addition, like if I bump it with my camera a little bit, you can see it getting pulled back. That's perfect. That's exactly what I want. Let's put on the turret by telling it can be targeted. And you can see it's going to get loud probably, so I'm just going to quiet down, but you're going to see the ship getting bumped around when it hits. There you go. Now, I just want to point out that it looked a little bit janky because it got hit, but it continued moving in the same direction it was moving anyway. Well, that's because the torque, or the direction, follows the velocity, the linear velocity. So that's not perfect. I think what I'm going to do is make it more like adjust torque to where it wants to face, or rather torque the pawn the appropriate amount based on different easing curves and different rotational springs, basically. It's going to ease and look at the target and converge on that direction, and as well as it's only going to have a force vector behind it. That means when you get hit from behind, it's going to be even crazy. It's going to, really knock you off target. And that's something I'm thinking about. That's why I'm saying I might redesign this stuff. But for now, it really works well. All you really need to do is maybe increase the angular stiffness. It's incredibly low right now. I'm going to bump it up to 100. Let's see what goes on. So it's a lot more reasonable, and you actually don't notice the that sliding effect too much. Either way, I think it totally passes, and it's exactly what I need at this stage, so I'm probably going to keep it for a little bit until I'm feeling good. All right, so this was kind of the player's movement dynamics, how I've set it up without the non-VR setup, rather. I do have a VR setup. It's just not every day do I want to be like, working with code and headset on my head. It's frustrating sometimes. You need to see things clearly. So you always need a non-VR setup of your test, I think. At least I do. All right, so I want to show you then what I've done here, this is where the pieces are kind of coming together. Gonna edit that cough out. Yeah. I got that, the cold cough thing, Not sick, don't worry. All right. So here's a setup where there's a lot of distracting stuff going on. This is a setup where I have an enemy ship up here. It's so simple. It's really just got an aim component, which I am not even using right now, and a spring movement component and a static mesh body, and that's it. And it is a behavior type pawn, which means that it assigns some behavior tree to it, and the its AI controller basically delegates entirely to this whatever AI tree you give it. So here's kind of what the behavior tree looks like. It initializes itself saying that it hasn't yet entered the fight. Then it does the entering the fight thing. So it's basically like warping into the right position. To do that, I'm basically saying, give me a point in front of the player and set the max speed to something really high. And again, this max speed thing, it's going to go all the way through the pawn. The pawn's going to, by default, reach out to whatever movement component it has. The movement component is my movement component, and that's where I'll be setting. Let's just check it out. I have an override, like set input, input vector. This comes in from the pawn, and I just take that vector immediately to be the offset relative to it, and this is now the new target, set target. Same as what I was doing elsewhere in that other test, except now I'm just setting the target. All right, so he's setting different targets based on whoever tells it, who knows? No one knows. He's just telling the pawn go there, and he's going to do it. What about other stuff? What about collisions? Like how is it going to avoid hitting something else, whether it's an asteroid or the ship, the player's ship, or like a funny geometry? That's kind of where this levels comes out. I don't know why those are so. I probably need to build lighting, probably. Yep. Let's do it real quick. So anyway, what I was saying was, I wasn't ever sure, or I haven't really been so sure what I was going to do for navigating for AI flight. The two options I have basically is an avoidance. Nice. An avoidance algorithm where it's kind of scanning for things that it might hit and trying to adjust accordingly. And the other alternative would be a 3D routing solver. And both of them, I probably think the first one's easier to implement, but the second one was one I did more work in already. So I actually picked up the second one. What it kind of means is that when you put the AI down and you say move from here to there, it's going to try to figure out a valid route between those 2 points. And it basically has full spatial knowledge. If it were a maze that I were in, it would know exactly how to get out of the maze, in the minimum amount of steps. So that's an amount of knowledge that I'm not sure I cared to give. I mean, it's not fair to give them that knowledge. That's, maybe they don't know. It's an asteroid field they've never been in. But that's thinking a little bit too much, maybe. The effect I want it to have is that these ships have good navigation skills. I don't want them to hit stuff. That's the most important thing. So I went with that. So basically, the navigation system is over here. It's wrapped up in this fly to node. It's going to determine the pathing. It's not going to do it that frequently. And then it's going to say it's entered the fight, and then it's going to proceed to the next sequence, the next selector, and begin chasing. It's going to try to find a point in front of the player. It's going to then fly to that point with routing. And here's a service I made to stay in front of the player, which honestly need to do a little bit more work in, but basically like if you're too close to the player, speed up. It doesn't change the point that you're going to. It only changes the speed. Okay, so I'm just gonna run it and just check it out. Check out what's going on. I've got a lot of debug traces, of course. One second. So here's I'm just gonna add a spring flight movement. In this case, it's mimicking the real world ship. I'll give it, not the spring flight, I meant spline movement. Giving it initial speed of 500 and orienting it to spline for the sake of whatever. And then I'm just gonna, I can't even do it. I'll just select the one spline in there. So moves the ship on the spline as if it's the player. That's all we really need to know. Okay. So the white ship is the enemy, and he's always staying in front of the player, so this is really good. Got some obstacles. He's figured out to, not crash into them. Perfect. Got another obstacle coming up. He's figured out the window through. Maybe I'll even block that window for him, so he'll have to go through another one. You get the picture. And so this is going to work for moving asteroid fields. It's going to work for all the other AIs I do. The one issue is that if you have a starting point and an ending point that is already inside a mesh or too close to it, then there's no valid route between them because they're both invalid points. So I actually need to do a little bit better job picking my points, making sure they're valid. But I can do that with a simple scan. And anyway, yeah, that's what's going on here. It's kind of cool, I think. A very good effect. And what's also very satisfying, I can't really show right now, but maybe I'll edit it in later. Now, when you shoot this guy, he's going to kind of have a little bit of turbulence because, we went a long way to achieve a certain effect, and it's finally coming together. So I'm really happy with it. Yeah. Sweet. Okay. Trying to record this video. All right, cool. So I just want to show you guys a quick little demo of what's going on here. I am really wrapped up in wires right now. I don't know where the wires are coming from. This is working, but I think I step over this one, and then I'm good. All right, cool. So I forgot I left a little mine in there, a little Easter egg, but see him swooping in. You can see him getting knocked all around from the shots, which is perfect. Exactly what we're looking for. And he's kind of trying to not get too close to me. Tries to stay out a little bit. That's looking really good. Yep, perfect.